Hello dear students, today we'll conduct an experiment on cross-flow heat exchanger unit. As you know, heat transfer can occur in three different forms: conduction, convection and radiation. For our equipment, the heat transfers predominantly by the convection process. Convection can be natural or free convection and forced convection. If the motion of fluid is generated by the external source, such as pump, fan, or suction device, it is this type of mechanism is called forced convection. As this is our equipment is related to the forced convection process, and we have three different types of. We'll compare the three different types of heaters in during our experiments, and the objective of heat at the same time we can say that heat exchangers transfers the heat from one medium to another medium by convection process. So the objective of our experiment is to investigate the convection process and make a comparison between different types of heater elements in different geometries, and to compare their heat transfer coefficients of these heater elements. At the same time, to find flow rate and to calculate different typical characteristic variables of heat transfer, Nusselt number, Reynolds number, are also our objective of this experiment. So let's demonstrate and show our unit equipment. Explain this unit. As you can see, our equipment comprises two main parts. This is the duct assembly, and this is the display and control unit. At the same time, our equipment is supported by the computer software. So let's look at this duct part. As you see, this is the air duct, and this is the fan. This part is the fan. The air is drawn through the duct by a fan. At the same time, here we have a hand lever, and with the help of hand lever, we can regulate the mass flow rate. And so let's put this on this position. And at the heart of the air duct, we have a heater elements. We'll insert the different types of heater elements one by one. As you can see, we have already fixed the one type of heater elements to here to the duct. This is the single pipe, but this is the finite pipe bundle, heater elements, and this is the pipe bundle elements, heater element. So before and after the heater, we have pressure measuring points. This is, as you see, this is the positive. It is indicated with the positive pressure, and this is indicated with a negative pressure measurement point. The pressure measurement points will be connected by hoses to the transducer. The transducer will convert the pressure variables, the differential pressure variable, to the electrical signal, and the electrical signal will be and the value of the differential pressure will be seen on this display, on this part. At the same time, we have thermocouples. And as you know, that thermocouples are the sensors which measure the temperature. We have two thermocouples here. One thermocouple will measure the heater temperature, and another thermocouple will measure the inlet air temperature, and both of them will be seen on this display and control unit. Here, as you see, this is the temperature of air, and this is the temperature of heater. Then, as you know, as we said before, this is the control and display unit. So we said that on the control and display unit we have, again, I can say, this is the temperature, this is the display of temperature of heater, and here we said that this is the temperature differential pressure, it's indicated here, and this is the power of heater will be indicated on this screen. And we have here two buttons, which fan and heater. We can switch on and off these two buttons. This fan, we can switch on and off the fan and heater with this switch like this. Okay, then we have here PC interface button. So in our experiment, we'll put this button on the manual part, and then we'll regulate the power with this switch, and our power which we gave to the heater will be indicated on this screen, on this display. But if you wanted to use the computer, so that when we switch this button to the PC, we need to set the target value, target temperature value on the computer, on the software, and the computer will regulate the power by itself on the computer. So, but in our experiment, we'll put it on the manual part, and we'll do our experiment manually. So, let's start our experiment. So, first of all, let's switch the fan on, then switch the heater. But we need to switch this button to the manual part, because we'll give the power value by manually by ourselves. As you see this one, if you want to calculate the pressure loss, you need to connect this positive pressure value to the positive pressure input on the pressure transducer, and negative pressure measurement on the duct to the negative pressure input on the pressure transducer, so that according to their markings. But in our experiment, we'll want to, in order to find the flow rate, we need to connect the positive measurement point to the positive pressure input on the transducer, pressure in transducer, and however, this negative pressure measurement point will be left open, and the holes of the positive pressure input on the pressure transducer will be left open, so that it will measure the atmospheric pressure. At the same time, students, so in our experiment, students will calculate this, will take this data, these records, and calculate their own results. They will find their Nusselt number, Reynolds number, flow rate by themselves, so that students will use these equations and they will find their results. At the same time, however, this computer software can calculate this also. And so at the end, the students can compare their results, their value, with the value on the computer software, on this computer software. And so, we can now we can give the power value. Let's start to give the 10 watts. Let's start the power value with the 10 watts. And look our experiment and observe our experiment. So we need, let's put it to which Okay, let's stop it on 9 watts. The power, we gave the power 9 watts, and as you see, the value of the power is seen on this display. At the same time, the computer, we can see this values with their calculations, with their calculations on the software also. So as you can see, this is the temperature of the inlet air. This is the flow rate. It's indicated here. At the same time, first of all, we need also change this parameter of heating elements from the computer, as well as it's a single pipe. That's why we'll convert it to the single pipe from this here. And we'll click this open house on the computer, because this is open house. Because of this hose is open on the transducer, pressure in transducer, that's why we click this open house button on this computer. And then we need to wait until the temperatures reach the steady reading. Then students should record these data. And then students also will record this data, and they will use these equations. The name of these symbols or written on this board is given on this manual. You can find their names if you want. The students can find their names from this manual. At the same time, the number of the characteristic range and the surface area are given on the manual. And the other variables also, you can find the other variables from the tables which is given on the manual. So we'll wait until the temperature reach the steady reading. Now this is 34.9, 35, it is increasing. And you can look this software part. As you see, the pressure variable, differential pressure variable is seen here. At the same time, you can see the same number on the display and control unit. And this is the system diagram of this equipment. And this is inlet temperature, the inlet temperature of the air. This is the heater temperature, as you can see on this control and display unit. And this is the power value which we gave. This is heat transfer, but these values actually students need to calculate by themselves, but the computer gives these calculations automatically and show this on the screen. Nusselt number, Reynolds number, heat transfer coefficients. And as you know, the heat transfer predominantly related to the Reynolds number and Nusselt numbers. Then it is the alpha heat transfer coefficient is seen on the screen. And this is surface area, which is given for each type of heater elements. But as we said before, if we switch to the PC button, then we need to set the target value on this button on this screen, reference variable, and then the computer by itself will regulate the power automatically. But now we use this manual button. So now, okay, I think this is the let's check the temperature. Okay, let's wait till the temperature reaches the steady reading. Now it is 35.5 Celsius degree. Okay, now let's check. We think that the temperature reached its steady reading. So students need to record this data, and then they need to calculate. And the calculations is already seen this part. You can see. Then the students can compare their results with the computer software. So now let's switch the power to desired value. Let's switch it to what? 220. Let's switch it to Okay, let's switch it to 19. Okay, now again we need to wait till the temperature reach the steady reading. As you see, the same data on the display and control unit can be seen on the software also. Let's wait some. So okay, it reached its steady state. It's 47.6 Celsius degree. So the students should record this data. Okay, now let's turn the power to which number? To 33. Okay, now wait. We change the power to 33 watt, and now we will observe the results. Again, we'll wait until the temperature reaches steady reading. So now, again, the third types for the single pipe type heater, students will record the data and they calculate their values by themselves with the equations. So now let's switch the heater elements to another type, to finite pipe. And for this we need to switch the we need to put this power to 0. Okay, and then we'll switch the heater off. After the heater, we'll switch the fan off. And at the same time, from the main switch, we'll also switch it off. So we have here main switch. So I switch this button off, and then I'll try to change the heaters, this type. Then I'll unscrew this vintage. Actually, it takes time, a little bit. Okay, so we have already changed our heater elements to finite pipe, and for starting our experiment, first of all, we need to switch the main switch from the back of the display and control unit. Switch on. We switched it on, and after this process, we need to switch the fan on, then switch the heater also on. And then again we'll give the same power values as we gave to the single pipe. So for the single pipe we gave the 10 watt for power, and now again we'll give the same power 10 watt to the finite pipe, and we'll observe the process. So at the end, we'll compare the heater elements with each other. So again, we'll wait for the temperature to reach steady reading. At the same time, you can also observe the process, the calculations, the process through this software, computer software. At the same time, as you see, the Reynolds number for the finite pipe. The Reynolds number for the finite pipe is higher because of its geometries and because of its higher characteristic length. The Reynolds number will be higher for finite pipe. And you know that Reynolds number shows the flow state of the fluid. So you'll indicate the temperature. And the next, again, we'll change the power to 20 watt. As we did for previously for a single pipe. Okay, and again we'll wait some time for the temperatures reach steady reading. Let's wait. So when it reached to the steady reading, we'll take the data, we'll record, and the next step we'll change the power to 33, yeah, as we did before for the previous heater element. Okay, then let's wait. At the same time, you can see the values of the finite type of pipe on the computer. So Nusselt number is 201. Heat transfer coefficient, you can see Reynolds number and other values. And as you see, we have changed the parameter of the heater elements from the computer to pipe with fins, as you see this part. Otherwise, the results, if you do not choose the correct parameter for the heater type, the calculations on the computer would be false, would be not correct. So as you see from the software, Reynolds number for the fin pipe is higher, as we said before, higher than the other type of pipes. And that's so that it is due to the geometrical shapes of the fin pipe, and it's because of the higher characteristic length of the fin pipe. And again, as we said before, the Reynolds number indicates the flow state of the fluid. Okay, now let's change. Now students will record this data. Okay, and now let's switch this off and observe the third types of pipe. So we'll switch this heater off. The fan will switch it off, and okay. Okay, and at the same time, from the main switch, from the main button, we'll switch it off. So we have already removed the fixed pipe type heater element, and now this third time we'll fix the pipe bundle heater to our air duct. But the pipe bundle will have the 4 positions. Because why, you can ask why? Because we have on the pipe bundle a type of heater, we have 2 thermocouples. As you see, this is 2 thermocouples, the sensors which measure the temperature. Because the thermocouples, as I can see, okay, you can see on the manual that the 4 positions can be for pipe bundle. That's why we'll insert the pipe bundle 4 times to the heater, to the equipment, to our equipment. So let's fix it to the duct. Okay, after inserting the pipe bundle to our duct, we switch the main switch on, and then we'll change the pipe parameter of the heater on the computer to pipe bundle. So as you see on this screen, we'll have for the pipe bundle we'll have 4 positions, 1, 2, 3, 4. But for our experiment now, we'll firstly we'll use this first position. So that's why we choose the first position, and now. And we fixed our pipe bundle in the first position to the duct. Then we'll switch the fan on, switch the heater on, and again we'll change the power to 10 watts. Let's give. Okay, then again we'll wait, and then again we'll wait until the steady temperature until the temperature reach the steady reading. Let's wait. And as you can see on the from the screen, on the screen the flow rate is calculated, and it's seen that 5.40 meter per second, and this is the pressure differential pressure. And as we said before, we click this open hose because our pressure input is open. The pressure input, the hose on the transducer is open, so now the heater temperature is 33.6 Celsius degree. Power is 10 watts, and here the calculations, as you can see, the Reynolds number is this value, Nusselt number is this, and the surface area for the pipe bundle is 464 meters square, and characteristic length is this pound. And due to the geometry of the pipe bundle, the flow will be more turbulent. And the heat transfer can affect, when we change the positions for the pipe bundle, for first position, second and third and fourth positions, in each positions, the Nusselt and Reynolds number will change. So we can say that the position of the the Nusselt and Reynolds number depends on the positions of the thermocouples. Depends on the positions of the pipe bundle. Okay, now we'll record it, and again we need to record this data, and the next time we'll switch the power to 20, as we did in our previous experiments. And again we'll wait till the temperature reaches to the steady reading. We'll wait. At the same time you can observe the values. Okay. At the end of our experiment, you need to compare the results for each type of heater elements. Okay, now it's reached to the steady reading. Now the next part will change to the 30 watts, as we did before for our other heaters. Okay, and again we'll wait. And as you see, the surface area and characteristic length is given for each type of heater. The surface and characteristic length is given on the manual, or you can take from this software. Okay, now students will record this data, and then we'll switch this off. We'll switch the power to 0, and then we'll switch the fan off, we'll switch the heater off, then we'll switch the fan off. Okay. And then we'll switch the main switch off. So we have done our experiment, we finished it. With the taken data from our experiment, we can compare the three types of heater elements, and we can calculate Nusselt-Reynolds number, we can calculate typical characteristic values for heat transfer. So thank you for your attention.